Hi, I'm Paul Kyogan from GK Tuition, and in this video I'm going through a question, and it's kind of a combination between complex numbers and sequences and series. The question we're looking at is 2015 Paper 1 Question 4 Part B. In this question we're asked to let omega be a complex number, and omega is not equal to 1, and omega to the power of n is equal to 1. S is 1 plus omega squared, the whole way up to omega to the power of n minus 1. Now just recognize omega is just a Greek letter, okay? And I'm going to talk to you about the relevance of why they're using omega at the end of the question. I'm asked to use the sum of a finite geometric series, which is this formula, in order to find the value of s. So the question itself looks very complicated. It looks like there's a lot of information, but they've told you exactly what to do. So you literally just, if in a question like this, you probably might be scratching your head a little bit. It said use the sum of a finite geometric series. So don't ask questions, just use the sum of a finite geometric series and then worry about it as you go along. So in this case, we just need to work out what's my Sn, what's my A, what's my or, and what's my n. So in a geometric series, A represents the first term. Clearly the first term in my geometric series is just 1. Or represents the common ratio. So the common ratio is any term divided by the previous term. So in this case, let's say we take the second term and divide it by the first term. It's just omega divided by 1, or in other words, just omega. So I know my A and I know my or. Sn is the sum of all of the terms. Well, I know that when I add all the terms together, I'm just going to get S. So that means that in this case, instead of Sn, I can just sub in S. When I add all my terms together, I'm just going to get S. And n is the number of terms. So I need to figure out how many terms are there in this sequence. Well, the first value is just 1. Okay? The second value is omega to the power of 1. The third value is omega to the power of 2. The fourth one will be omega to the power of 3. Which means that the nth one would be omega to the power of n minus 1. So if the third one is to the power of 2, then whatever this one is, it's to the power of the previous number. The previous number is n minus 1. This must be the nth term. There must be n terms in this sequence. So that just means the number of terms I can just sub in n. So once I've worked that out, I can now just sub it in, and it works out incredibly straightforward. So the question was to find the value of s. So in this case, s is going to be A, which is 1, times 1 minus or, which is omega, to the power of n. And that's all over 1 minus my omega, minus my or, which is omega. So if I just simplify this down, my top line is 1 times 1. And remember, at the start of the question, it told me that omega to the power of n was equal to 1. So in my bracket here, I actually just have 1 minus 1. And that's divided by 1 minus omega. Notice on the top line, I have 1 minus 1 is just 0. So this actually just works out as 0 over 1 minus omega. If you have a fraction with a 0 on the top, then it's just 0. So actually your s, if you add them all together, they just work out as 0. So when you add them all together, they must cancel each other out. So I think that question just looked very difficult. And not only that, I think if you did this in an exam in the Leaving Cert, you'd think you did something wrong. Like you would worry that why is everything cancelled out? I think your inclination might be there that you'd actually be stressed that you've got something wrong. So I think the key is in June, just trust your instincts. If you get something strange, as long as you follow the rules of maths, then you could be right. As long as you follow the rules of maths, then just trust yourself and don't second guess that you think you've gotten this one wrong.